Hi V. This is the mock exam. These are my notes. You know, my my roommate helped me, so hopefully this helps understand some of the stuff. Um, but yeah. Anyway, so for the first one, what you want to do, first thing, like for all of these problems, really, you just want to make sure and you want to see if you could plug this number in right here, right here. So you want to see if that can go down here. And as long as this doesn't equal zero, as long as it doesn't equal zero, then you should be good, right? So, so that's the first thing you do, right? So you try and plug in zero, right? For, or sorry, you try plug in five for x. So you do that, right? You plug in five, and we see down here in the denominator, it doesn't equal zero, right? So it works. So we can continue doing it this way, which is really just algebra, just simple algebra. So shouldn't be that hard. So you plug it in, right? And so then we just solve for the limit. So we go, 5 minus 4 is just 1 here. 5 plus 5 is 10. So, we have 1 here, we have 10 here. And so log 1 is something very important to remember. Log 1 is just 0. That's just always 0. So knowing that, we just have 0 plus e to the sine of 5 and over 10, right? So anything 0 plus whatever is just the same thing, right? So we could just get rid of the 0. And so our final answer should be e to the sine of 5 over 10, since we don't really know how to compute this without a calculator. So assuming we don't have a calculator, this is going to be our final answer. So not that bad for the first question. Not that bad. So, you know, just how I said for the last question, you really just want to make sure that you're able to plug in 0 for x, and if you can, and the denominator isn't 0, then you can go ahead and do that. So, but some important things to know is that cosine of 0 equals 1 always, no matter what. Cosine of 0 is the same thing as 1. So we have cosine of x right here, and the limit says that it's approaching 0. So if we were to plug in 0 here for x, it would be cosine of, or it would be cosine of 0, which is 1, right? So this is 1, but we have a minus 1 here. So 1 minus 1 is 0. So we would have a 0 down here, and we don't want that, right? We don't like that. So we know that. So we can't use 0. We can't plug in this time. Something else that we should know is that the range of cosine is -1 and 1. So basically what that means is that the graph of cosine usually looks like this. It just oscillates between 1 and -1 and never goes beyond that. So it just stays there. That's the range. The domain, I mean, it's irrelevant for this question, but the range is something very important to know, that the graph of cosine, the range of cosine, oscillates between -1 and 1. Okay, that'll come in handy later. You'll see why. So, all right. So since we can't plug in 0, or sorry, we can't plug in 0 here because it'll end up with 0 as a denominator. Next thing we could do is we could check from both sides. We could do a test. So basically, so we know that x is approaching 0, but isn't really 0, right? So what we do here is we try to find a number that's really, 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 really close to 0, but isn't 0. So, an example of that could be like, 0.000000000, and then a little 1 at the end, right? We could do that. I mean, we could go, really far, but that would be really tedious, right? So let's just say for our first example, for our first test, let's just say 0.01. That's pretty close to 0. So, and we know that cosine of 0 is equal to 1. So what would a cosine of something really close to 0 be? Well, what's something really close to 1? I mean, for example, we could use 0.9999. I mean, that's really close to 1. Um, so, you know, it wouldn't be the exact number for this, but we could assume that since this is really close to 0, or sorry, this is really close to 0, then cosine of 0.01 should be really close to 1. So let's just use 0.999. And we know that there's a negative 1 here, or a minus 1. So let's not forget that and put that, let's just leave that right there. So if we compute this, we would get a negative number, negative 0.01, let's say. All right. So now we have this under 1. So this could also be written as negative 100. All right. So that's just something you should know. If you don't know, this is something very important. Okay, we got negative 100. So we just computed this whole thing using 0.01. Okay, what if we do another test? What if we do something even closer to 0? So let's do a few more zeros, you know? Let's see what happens when we do that. So for our second test, we put a couple more zeros to get even closer to 0, right? And so we know that if it's getting even closer to 0, then cosine of closer to 0 should be closer to 1, right? So we add even more 9s to 0.9999, right? So we get closer to 1 once we compute cosine of 0.000, you know. And then we just do the same thing. We just bring down negative 1, we compute this, it's this, negative 0.0001, and, you know, we bring this one, then remember, we got to remember this, you know, remember that this is on top of this, right? So we have this now. And we know that this could be also written as negative 100, or, you know what I mean, right? So what are we seeing here? So as this number is getting really close to 0, we're getting a bigger, we're decreasing in negatives, right? Or we're increasing in negatives. See, we're getting negative 100 and negative, I think 10,000. I'm not sure what, but you get what I'm saying. So we keep going, right? So let's keep that in mind. So we could assume that this is going all the way to maybe negative infinity. So let's try the other side, because remember, we have to do both sides. This is just from one side. This is coming from the right because we're using a positive number. So now let's try it from the left side with a negative number. So negative 0.01 coming from the left side, right? And remember, you know, we want this number to be we want this to be really close to 0 but not 0. So cosine of something really close to 0. Now let's think about this. So negative 0.01 cosine of this is just really close to 1, right? So one of my questions was, why isn't this a negative 0.9999? So, hold on. Oh, sorry. My mistake. That's for a different problem. We'll get back to that later. Anyway, this could be equivalent to this, but we see that this was already, we have already seen this before. We've seen this right here, right? So we could just assume that we repeat the steps that we did here, right? So if we assume that this just repeats, and if we assume that if we keep adding more zeros here and keep adding more 9s here, then it should also be increasing or going towards negative infinity. So both sides are approaching negative infinity, meaning that the limit is just negative infinity. So that's for that one. Here, let me just give me a break and let me try and regroup. All right.